Hi, good evening. So myself, Mohammed, Assistant Professor, Department of Electrical Electronics Engineering, KPR Institute of Engineering and Technology, Coimbatore. So we are going to discuss about the purpose of starter and DC motors. So generally, the starter is not used to start the motor. It is used to limit the starting current of the motor. So the main purpose of starter is used to limit the starting current of the motor. So in general, the starters are used in AC machines as well as in DC machines. As well of machine is concerned, so there are two classification. One is called as a motor and generator. So we are using the starters for motors of for AC machines as well as for DC machines. As of DC machines is concerned, so we are using an 2.3.4 point starters. As of AC machines is concerned, we are using an direct online starter, star delta starter, auto transformer starter, and etc. So as of today, we are going to discuss about why we have to use a starter. Okay, so we are saying that it is used to limit the starting current. So how the current is increasing and why we have to limit the starting current. Okay, so for that, so I have taken example as an DC shunt motor. So the required voltage, current, power and speed we are assuming as an 220 volt as an rated voltage, 20 amps as an rated current, rated power as 5 kilowatt and rated speed as in 1500 rpm. So I'm substituting the rated current here. So 20 amp, when we multiply and divide, so we'll get an current of 25 amps. So this is a maximum current that the machine can able to withstand. So about rated current, the fuse gets burned out. Okay, so the machine can withstand the maximum current of 25 amps. So what may be the starting current of a machine at instant? Okay, so for that purpose only, so we are going for a starter. So in this is often DC shunt motor, so we are using a 3-point starter. Okay, so write the voltage equation for the DC shunt motor. From that we can able to find the current. So this is an applied voltage V. The current flowing into an armature current is called as an IA, and the resistance, armature resistance, is called as an RA. So the voltage is created. The voltage is called as an back EMF, which is approximately equal to the applied voltage V. Okay, so hence the voltage equation is written as V is equal to EB plus IA into RA. From this equation, so we can derive IA. So IA is equal to V minus EB divided by RA. For example, if I assume V is equal to 220 volt, at the instant, what will be our back EMF? At instant, back EMF is 0. Okay, so the armature resistance is very minimum, that is we are assuming it as an 0.2 ohm. So substitute all these values in the above equation. IA is equal to 220 minus 0 divided by 0.2 ohms, which is about 1100 amps. But our machine can take up to only how many amps? It is only up to 20 amps. So we can able to see here the starting current, that is at instant it draws 1100 ampere. Okay, So in order to reduce the current, so high resistance is added towards an armature side. Okay, so that high resistance is called as an starter. The high resistance is called as an starter. So as of DC shunt motor is concerned, so we have to go for a 3-point starter. The 3-point starter consists of an 3 terminals. So line, field and armature. So I am drawing a simple diagram for example. Okay, so this is an high resistance which is connected to an armature of the DC motor. Okay, so armature of the DC motor. So when the resistance is high, the current flow is low, so the EB is also low. When resistance is reduced, the current flow is increased, so the E back EMF is also increased. So this is at instant so the second condition is that in position of the starter. So at this condition, so the EB is minimum, so we can assume it is equal to 0, and this condition the EB is maximum. So EB won't reach the value of the applied voltage, so it is always less than or equal to 220, that is an applied voltage, that is here we have assumed as an 220 volt. Okay, so the equation becomes, so IA is equal to V minus EB divided by RA. So the V is 220 volt, EB may be 218 volt, and RA is equal to 0.2 ohms. So if we substitute, IA is equal to 220 minus 218 divided by 2, so we'll get an 10 amps. So this shows the current is reduced when there is an increase of EB. Okay, so while increasing the EB, so we are in need to gradually reduce the starter resistance in order to protect the armature of the motor. Okay, so kindly go through it so you can able to understand. Thank you all for the patient listening.